Okay, example 2. A train starts from Toledo at 11 a.m. and heads for Mackinac, 332 kilometers away. At the same time, a train leaves Mackinac and heads for Toledo, 65 kilometers per hour. The trains meet at 1 p.m. What is the rate of the first train? So, we have two trains in different towns. Okay, so we have one train in Toledo, one train in Mackinac. They both leave their station at the same time, headed towards each other. They're both going some speed, right? So they're both going to move some distance apart. They're not crashing. Okay, so if I were to draw arrows representing their travels, the Toledo train will travel some distance towards the Mackinac train. The Mackinac train will travel some distance towards the Toledo train on a separate track. Right? So the total distance traveled by the two trains is the distance between the towns, which is 332 kilometers. So we're going to say that this distance here is the distance traveled by the train leaving Toledo, and this is the distance from the train leaving Mackinac. Okay, so that's the way I decided to set it up. Okay, looking at that picture, so the same type of picture last one was. Last problem, the two buses were going opposite directions, creating this total distance. Now we're starting a distance away from each other, going towards each other. Both trains together make the total distance. Neither one individually does. So I know that the Toledo distance plus the Mackinac distance is equal to the total distance. So the problems from lesson 94 are going to be like that each time. But again, drawing the picture to get that understanding is important. That way when they start mixing up the problems, made the same trip, distances are equal. This one went this far, this one went that far, you know, the total distance is whatever. All right? They'll add up to this, add up to a constant. As before, I've got my chart here, I've got it right here, time here, and distance here. I can see once again we're dealing with kilometers per hour for a rate. So hours per time and kilometers per distance. So, train starts from Toledo at 11, heads for Mackinac, 332 kilometers away. Same time the train leaves Mackinac, heads for Toledo, 65 kilometers per hour. Trains meet at 1 p.m. All right, so train from Toledo and from Mackinac. All right, so how fast is the train from Toledo going? The one that leaves Toledo and goes towards Mackinac.
65. We don't know.
We don't know that one, right? So they don't tell us the rate of this one. We'll call that R. The train leaving Mackinac heading for Toledo is going 65 kilometers per hour. All right, so that's job one. We've already used a variable, so now we have to know the times. And then notice that a train starts at 11 a.m. At the same time a train leaves Mackinac. So both trains are leaving at 11 a.m., right?
Yeah, so
And they meet at 1 p.m., which is 2 hours, right? So elapsed time of 2 hours. So again, when they start giving you time on the clock, that's how you establish elapsed time. From 11 to 1 is how many hours? 11 to noon is 1, noon to 1 is 2. All right. R times 2 is 2R for the distance from Toledo, so that would be this one. And 65 times 2 is 130, that will be that one. So 2R plus 130 is equal to 332. Move the 130 over. We get 2R is equal to 202. Divide both sides by 2. We get 101 kilometers per hour. A little bit faster than 60 miles per hour. But 101 kilometers per hour. And that's what they're asking for. What's the rate of the first train? First train, the one coming from Toledo, it speeds 101 kilometers per hour. The only other question they might have asked me is how far did it go? The answer would have been 202 kilometers. So we'd be able to find either one of those answers once we get the first piece of information figured out.